I have to go and find a broomstick. All right, time. Take it away.
Okay. So, good afternoon, everybody. We had really nice and professional presentations, but I have 40 slides in 20 minutes, so I will try to be fair. I'm Spanish. I can talk really fast if I propose to. So, my name is Helena Vela. I work for DoIT now, but that doesn't really matter right now. I'm here to represent EESSI, and I'm going to make you a status update on the European environment for scientific software installations. Status update since when? Well, we presented it for the very first time here at the FOSDEM 5 years ago by our colleague Bob, and he presented EESSI one scientific software stack to rule them all, and I hope to keep you convincing about that after all this presentation. So, what do we want with EESSI? Calibration test. How many of you actually work in HPC? Okay, then I don't have to over-explain. What we want with EESSI is to provide a truly uniform software stack, and that means that you will find the exact same software everywhere without sacrificing on performance, because we are doing high-performance computing, and I want to think that the word performance actually means something. And you know that if you compile a binary for everything, it usually doesn't work that well in performance-wise. And to avoid duplicate work, because we are all in this together, we are researchers, we are users, we are user supports, we are system administrators, that we have to install the exact same thing everywhere in Europe, and it's just not practical. So we have tools like EasyBuild and SPAC that help us doing that, but at some point it's not enough, because you can share your EasyBuild recipe with somebody and it just won't work for them. So we are not just sharing how to build them, we are sharing directly the binaries, and we are working all together into a shared software stack. And this way we facilitate HPC training, development of scientific software, but more on that later. And with this, I go to the demo, I hope to. Maybe Kenneth can help. Okay, so this is my laptop. As we are at the FOSDEM, I feel obligated to say that Ubuntu is not my preferred choice. It's a company policy. So you can see it's an Intel machine, nothing fancy here. And if, it's an Ubuntu, right? So nothing super fancy. If I now do, also, if I do a module avail, I have lmod installed because it's a dependency of EasyBuild, but not because I'm actually installing things here. So if I do now a source, this script, which is the easy initialization script, magic will happen if eduroam allows us. Okay, this is expected because my installation is a bit broken. But if I do module load this thing, magic happens, and now we have all of this software stack available for me. And you can actually load things and use them, like Romax. If I now do Gmax help, it just works, right? And the same thing if this is a development environment we have in our company. Also, again, Intel machine, but this as this is a Rocky Linux, so better choice of operating system there. If I know, again, okay, if I do module avail, not even lmod is here installed. And if I now do the source of the script, okay, it actually picks more things here. I don't know what happened with my local installation, but it's okay. You will see that it detected the architecture, that it's an Intel machine, and also the microarchitecture. If I now do module avail, we have the exact same software stack in both of the machines. And now I come back here, and thank you, Kenneth. Okay, this is the backup in case it didn't work, but it worked, so I'm going up. It looks like magic, but it works, and you have seen it, and this is the way it works. So it's like a layer design. You have your machine architecture underneath. It can be anything from Intel, AMD, ARM, and RISC-V. Yes, that's possible. It works too. And on top of that, you have the host operating system, which is the one providing the drivers. That can be GPU, network, whatever. Also the resource manager, usually is Slurm. And then on top of that, you have the file system layer, which is CERN-BMFS, which is another open source project. We have developers right here if you want to ask something to them. This is the infrastructure to distribute the binaries, not the binaries themselves. And then on top of that, we have the compatibility layer. I hope that with this audience, I don't have to introduce what EaSSI can do. but basically you can install it in a particular prefix, and so it's like you have a container without being a container. And now all the software installations we do in the software layer, these are the binaries. They all point to this compatibility layer, so you make sure that all the glibc is the same one, and that's how we make it to work for every operating system and machine in the universe, probably. And we build this software with EasyBuild, of course, LMod, and then there's ArcSpec, which is this library that helps us detect what's underneath. And we test all of this thoroughly through Reframe. This is the infrastructure we have to distribute the binaries. It's all hosted in the University of Groningen. And then it's replicated through various servers in Europe, US East and EU West, and a new one in the UK I didn't know about since this morning. And basically, everybody who has EaSI installed goes to fetch that there onto or to a proxy. So you can see everything is in Europe, everything is nice and trustworthy. Okay, this is not going to be an actual demo, it's just to show you that BMFS, you can install it with these very simple, easy commands. The thing here is that obviously you need to be the administrator of the machine to be able to install it, which if it's on my laptop, it's not a problem, but if it's an HPC cluster, you will probably have to fight a lot of people to get this installed. So what if we don't have this privilege? There are many, many ways to install, well, to access EaSI. You can do it through a container, you can do it through CERN BMFS exec, which is provided by the same file system, and some other tools. I could be an hour talking about them, but you have them linked in our documentation. So there are ways, even if you have access to a cluster, but maybe the compute nodes don't have internet or things like that. So now the actual new releases and developments we have been doing. So when we presented the project, it was a pilot. The pilot.dz.io repository died already. And the production ones are the software.dz.io. And the default one has been the one in 2023, the one we released then. And it has more than 1,000 software packages installed. That's per target. That means that the total is 16,000. But it's a bit old already. The software that's in there, it's compiled with GCC up to 12.4. So now we're working on the new release, the 2025 one. It's already available. It has already 500 software installed. That means 7,000 in total. And it's everything compiled with GCC 13 up. And then we have the dev.easy.io, that's the developer one, but I will talk more about it later. And we have the RISC-V one, which it was for the RISC-V software. But it kind of died. It was sort of the developer one. So more about that later. This is the evolution of the software we installed. You can see we have been doing quite a steady progress. This is for the old stack. And this is for the new one. So I hope we can reach soon the number of installations we had in the default one. And this is a nice good thing with it, like a word cloud with the software we have installed in EaSI. You can see we really love EasyBuild. It's the software we have more versions of, but it features other superstars of scientific computing like MPI, Python. I want to say Java, but it's here. All these tiny kind of packages, because it's not only big scientific software installations, but it also has a lot of bundles like Python bundles, Rust bundles, Perl bundles, blah, 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 blah. So many things you can find in there. Also the new CPU targets, when we started, we would only build for the generic ones of the big architectures, and now we feature much more modern and nicer architectures. And it's really important that we support as many of them possible, because the plan is to support all the machines already available and in the future in EuroHPC. And who knows about EuroHPC? I hope a lot of you. Okay, because then a word from our sponsor is that EuroHPC, it's like the father project that gives money to all of us, and especially to countries to put their own supercomputers, and also to the projects we work. This being said, what about the GPUs? Well, the support is in there, but it's a bit complicated, because CUDA has a license that doesn't allow us to redistribute it, obviously. So we had put 2 helper scripts to help you like fetch the CUDA from the system and inject it into EESSI so we can find it. And we have actually CUDA-enabled software in EESSI, like CUDA samples, GROMACS, Expresso, blah, 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 blah. And PyTorch and TensorFlow, I'm quite sure they are there, right? No? Okay. But I've seen issues, so, okay. So this is complicated, but we are working on them. And about AMD, it's also a work in progress. And it's nice because you can have combinations of AMD CPUs with NVIDIA GPUs. And it does not only support a wide range of architectures, but also like the interconnect through the machine, like InfiniBand. And as I said, the goal is to support all of the your HPC systems, present and future, because, for example, Jupyter is not in production yet, but we built all the software for the NVIDIA Graces, so EESSI will be there with all the software ready for when the machine is in production. Something that also got a lot of love and attention is the build, test, deploy bot. And this is the whole CI infrastructure we have for adding software to EESSI. Like you open a PR to EESSI, and this bot will start, well, we command the bot to start to build for all the targets we have. The bot will build them. It will test them because it's important to us. And if everything is okay, the bot will also deploy it into the repository. And it's a lot of runners running into a lot of machines that can be HPC clusters, they can be cloud environments. Also, sorry, I got the track mentally. But it's important to note that the bot doesn't obey to everybody. It's really important to be secure, so if you open a PR, you cannot do this. We need to do it. Okay, so I said software testing is really important part of EESSI. So, you know, EESSI build already does its own sanity checks, but we also do a lot of regression testing through the test suite. And that's a lot of reframe tests running constantly in different infrastructures. It can be like HPC clusters we have access to, but it can also be like VMs or cloud machines. And it's better to show you also, but I can manage. This is dashboard.eeessi.io. You can select the benchmark you want to run, well, that you want to see the data of, and you have this Pollock kind of painting here. But so you can see, like, this is for GROMACS, but maybe for something else like TensorFlow we can see better if it loads. Well, anyway, at any point it's like the result of the benchmark for that day in that machine in particular, and you can see how much it took. And this is not a scalability thing, this is like a performance thing. So the flatter the better. That means that all your machine is running fine, you have no surprises, none of your nodes it's shitty or dying. It's okay. So it's really nice, and you can obviously filter all of this mess so you can see it properly. Going back. Okay. This is what I just said, and it's also we also accept new systems. So if you are interested into this constant benchmarking, please let us know. Also, of course, EESSI, it's an open source thing. You can open a PR in case you want to see some software added to it. We have a contribution policy though, so we ensure some quality. And what if you want to build on top of EESSI but you don't want to contribute to it? That's also pretty valid. You can do it with EESSI build or throwing yourself into the void and risking to compile it manually. So with EESSI build, it's really easy. You just do module load EESSI extend, and the environment will be set to you to just start building with EESSI build. And if not, you can load the built-in module, and that would load airpath wrappers and all the weird flags you have to set, like blapack, blast, blah, 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 blah. But we didn't test this too much. Okay, so in case somebody of you wants to try it and give us feedback, then it's also really valuable for us. And what about if I want to build, to use Spark on top of EESSI? That goes later. Now dev.eeessi.io, this is the development repository. And it's really nice because probably most of you are developers. You have to test your code in a lot of your HPC machines, or maybe it's just different machines. You can install from commits, you can install patches. It's not meant to be in production. You can also skip CPU targets if you're not really interested into testing there. and it has just some different folder structure, so you can put many versions. So it's really, really nice because you want to test your software, you just push it into EESSI, and in some minutes, hours, whatever, you will have it already available in a wide range of machines to test it. And for the moment, it's only available with the codes we have within the multi-scale project, which is the one that gives money to us to develop all of this. But maybe in the future, we accept more. Also, further integrations, and I will speed run this because I have only 5 minutes. This is what I said before. The aim is to have them in all the HPC machines. We have them in Deucalion, Mare Nostrum, Leonardo, Discover, Carolina, Vega, and Jupiter. It will be available since the 1, and then in Lumi, and Meluxina is a work in progress. So good job for the moment. But thankfully to the European Federation platform, which I don't have time to explain, EESSI will be the official software stack for the HPC machines. If you want to know more, there's a series of webinars starting next week. You can attend them for free. Just register or ask me later about what it is. Also, EESSI has been integrated in the European Open Science Cloud. That's another kind of compute resources you can have if you're a researcher in Europe. EESSI is just there. Actually, don't know much about this one because I haven't used it. And then we have EESSI now inside Open On Demand, which is a web desktop-based application. It makes HPC access really easy for newbies and super, super nice. I could be also an hour talking about how great Open On Demand is, but we don't have the time. So if you want to know more, just ask me later. And now SPAC. So non-ironically, every time I give this presentation, somebody asks me about SPAC. So at some point, we started working about building with SPAC on top of EESSI, and it kind of works. We have a proof of concept in our blog. You can visit it yourselves and read through it, because this is also a talk worth an hour. But there's the work in progress. It's coming, no worries. And about trainings and dissemination, we always find that people doesn't know us very much. So we have been busting our asses to talk about EESSI and spread the word everywhere. And one really nice thing you can attend is the happy hours. It's every Monday from 2 to 3. It's via Zoom. We just we talk about EESSI, some topics, some updates, and then we just have an open discussion. They are also uploaded in YouTube if you want to see them, the former sessions, I mean. Also, webinar series, we have done this one last year, and we plan to do another one this year, so you can deep dive into the topics of EESSI. There are quite some of them, and they are really like long videos. They are also in YouTube. Also, we have, as I said, we have traveled the world and the 7 seas to spread the word of EESSI. This is just some of the dissemination effort we have done, and probably more to come. And of course, winning the HPC Wire, the Reader's Choice Awards. In my brain, it's last year, but it's actually 2 years ago. Super, super nice, especially because it's the one that people vote, not decided by the magazine. And if you have any problems or whatever, take a picture to this. You can open a GitLab issue, and it doesn't actually have to be a problem. You can also send suggestions, report problems, request things. We will be there to help you, thanks to the multi-scale COE that gives money to have a support team. And okay, this is the one you actually need to take a picture of. You can join the EESSI Slack. You can look at the documentation. You can look at the blog. You can look at the paper, and you can look at the YouTube channel. We have a lot of resources there. And, well, these are the socials for the multi-scale project. So I will leave this one, because I see phones taking pictures. So I think that's it, and we have time for questions.
This kind of speed run only works with Spanish people. Great job. Questions for Helena?
Go. Sorry, which slide?
The slide with the heart.
Yeah. The question is if I can go back. This one.
So there is Meson mentioned there. Which HPC software is actually built by Meson? Because my colleagues so far haven't been convinced about anything other than CMake, so I'm curious.
So the question is, if you want to torture yourself with CMake, you can do it.
And they let you choose.
But then you have to be careful how you can configure it, because sometimes you can configure it in one way through CMake, then if you use Meson, you lose that. So sometimes it's a bit picking as well what makes sense, but we see it more common. It looks like people are moving away from CMake for some reason, but good.
For some unknown reason. Okay, go.
What does the open-on-demand application do?
It's really. Oh, sorry. What does Open on Demand do? It's a web-based interface. So basically.
No. The easy application.
So what does the easy Open on Demand do? It opens a desktop, which you can. Okay. There's like this Easy General app, and if you can see at the module list, those are modules from Easy. So it just opens a desktop that's interactive to use. Graphical desktop, yeah. So it's really beginner friendly, and you have like all the modules from Easy there available. Okay, somebody else? No? Okay, go. Okay. So the question is if we can basically put very outdated software into Easy. I mean, why not? If you have the need, why not? But yeah, if it can be why not? Just why not? Okay, go.
I would say the biggest issue is if it builds with a recent compiler, or if you can make it build with the recent compiler, fine. If somebody still needs it, if they want to use old junk from 10 years ago, I mean, maybe it's important to reproduce papers or God knows what, but if we can get it to work and if it's open source, then sure.
Yep.
Related question, like how do you determine what software to redistribute? Even like suppose there are like 2 or 3 users, would you do it, or like what are the criteria?
The question is, what's the criteria to redistribute software? I think the main stopper here is the licensing thing. Like, if it's open source, whatever, just why not? If it's closed, then you won't be able to do it, basically.
Is there no requirement for like at least so much interest or at least so many users?
No, I don't think so. No. Okay. So the question, what's the process to add a new microarchitecture? I actually don't know this one.
So painful is part of the answer, because everything we've installed up until now, if we introduce a new CPU architecture and do optimized builds for that, we do everything again, right? Now, thanks to EasyBuild and the fact that we know EasyBuild well enough, we have scripts that help us to harvest things and build things in the right order again and make sure it all works out. There are hiccups though. When you're targeting a new CPU target and you run a test suite of, say, NumPy, there's often surprises in there. And we do what we can to figure out the failing tests. Is it a problem with the test, or is it really an upstream bug? Do we need a patch to fix that issue? So there's a lot of like these hurdles that we have to overcome. We've now done it multiple times. We'll do Neoverse v2 soon. Actually, Neoverse v2 is a bit complex, because what you actually want is you want like Graviton 4, and what is it, Google Axion is a Neoverse v2, and then Grace. You actually need separate builds for each 3 of them. For each of them. It's not that easy to come up with Neoverse v2 that if you fully optimize it and use all the instructions that you can, you're like missing things out. So you have to build, we already built for Grace separately, but you cannot Neoverse N1, Neoverse V1, Neoverse V2. There's an issue that I can point you to. It's a lot more complex than that. So it is a painful thing. We're selling Graviton 4 and 5 is 2 that we want to do quite soon. The other one is Zen 5, so the AMD Turin. And it's just work, yeah. We build again from the bottom up, and we powered